ArangoDB 3.8 is out, and it comes with a major addition to its query language AQL. The new window operation allows you to aggregate time series data, but it is not limited to that. Common use cases include to calculate rolling averages and running totals using a sliding window. In this lunch break special, we will take a look at this new feature, how it works in a visual way, and how it works in AQL. Let's start with an overview over the different variants and their syntax. What they all have in common is the window keyword followed by the aggregate keyword. You may already be familiar with aggregate from collect operations. The first window operation type is row-based aggregation. After the window keyword, there's an object with two attributes, preceding and following. They let you specify how many adjacent documents you want to look at and aggregate at a time. If we picture the data in a collection as a table, then they are the rows before and after the current document. The second type is range-based aggregation. Here it's not about adjacent documents or rows, if you will, but it's a value range that you specify also with the preceding and following attributes. But now there's a reference to a document attribute and the with keyword before it. The third type is duration-based aggregation, which is a subtype of range-based aggregation, but not using a value range, but a time interval. A timestamp is referenced after the window keyword, and in the preceding attribute, in this example, there's an ISO period string that defines that the previous 30 minutes should be aggregated. We will use a minimal example dataset for illustration purposes here, and the documents look like this. They all have a timestamp, then there's a subject, which is sort of a group name, and then there's a numeric value. To make it easier to understand, we will look at this data in table form, where each row represents one document. Now, in row-based aggregation, we want to aggregate adjacent documents or rows, and we should ensure that there's some order before we do the aggregation, otherwise it will be somewhat random. Here, the documents are sorted by time. Here is a visual example. We highlight the active row in yellow, and we say that the window is supposed to cover one document before and after the current document, that is preceding one and following one. In case of the first row, there is no preceding row, so it's just the first two rows that fall within the window, and then we can aggregate the values here in the rectangle, that is 10 and 0, and can say we want to calculate the rolling sum and average. The sum is 10 plus 0, that's 10 divided by 2, which is the number of rows, then we get an average of 5. And then we can move to the next row. And then we keep sliding that window over our data and calculate the sum and the average or whatever other aggregation expression you want to use. And in case of the last row, there is no following row, so like in the beginning, we only use the second to last and the last row to calculate the values. Here's how we can do this in AQL. We iterate over a collection, here called observations, and we sort its documents based on the time attribute. Next, we define the window to span from one document before to one document after the current document. And then we aggregate these three to the rolling average and the rolling sum using the average and the sum function. And then we return all of these values. On to another example. We define our window to be anchored to the starting row using the special value unbounded for preceding and no following rows in this case. And now we can use this to calculate the running total, or also called cumulative sum, by growing that window over the values and adding up the numbers, as you can see here. And this is how it's done in AQL. We define the window to use the special value unbounded for the preceding attribute to use all of the previous rows, and we set following to 0 so that we can then aggregate all of the values using the sum function to get the running total or cumulative sum. Note that you can combine the two previous window aggregations in a single query like shown here. So far we aggregated documents sorted by time, but regardless of the subject value. But that's actually a common use case to aggregate the data for like each sensor or server ID, for instance. So let's take a look at how we can first group by the subject and then do individual aggregations per subject. We iterate over the collection and use collect to group by subject. Then in a subquery, for every group, that is, for each unique subject value, we sort by time, define our window, and aggregate the data. And for every subject, we return a result in the subquery. And outside of the subquery, we flatten its result for convenience. In range-based aggregation, there is no window based on adjacency, but using a value range to aggregate documents. And what's noteworthy is that unlike with row-based aggregation, there's no need to explicitly sort by the value attribute because this happens automatically. In this example, we use a window with the range of -10 to +5 relative to the val attribute. That means for the first value of 0, the range is from -10 to +5. And if we aggregate that, the sum and the average are 0 plus 5 for 5. Divide that by 2 rows. That's an average of 2.5. Then we can continue to the next row, which is 5. So the range is -5 to +10. And that's the same for the values 9 and 10. The window doesn't change in that case. Then we move to 20 with a different window, and that's the final result here. In AQL, this looks like this. We define the window to use the val attribute as reference, and the value range is defined again using the preceding and following attributes. And the range is supposed to be -10 and +5 relative to this value attribute. With duration-based aggregation, we can aggregate documents using a time interval as a range. And we do this by specifying an ISO duration string, such as P1D for 1 day or PT30M for 30 minutes. Like with the range-based aggregation we saw before, there's no need to explicitly sort by the time attribute because that happens automatically. For this example, we will use a window of the preceding 30 minutes, and we will leave out following, meaning an empty interval. In case of 7 o'clock, that means everything from 6:30 to 7 o'clock, which includes the first 2 rows. And then as we approach the third row, the window changes to 6:45 to 7:15, and we continue to aggregate the values, and this is the final result. And here's the AQL query for this. We define the window to use the time attribute, which we actually have to convert to a proper timestamp first from an ISO string, because that's what we use in the example data set. And we say that we want to aggregate the preceding 30 minutes. We leave out following here, which is equivalent to saying it should be like 0 minutes or 0 days, so an empty interval. And then we do our aggregation. I hope I sparked your interest in this new feature, and if you want to get started using it, then download ArangoDB 3.8 and check out our documentation. Link is in the description. Thank you.